Hello friends, today I'm going to solve LeetCode problem number 86, partition list. In this problem, we are given the head of a linked list and a value x, and we need to partition the linked list such that all nodes less than x should come before all the nodes that are greater than or equals to x. And we also need to preserve the original relative order of the nodes. Okay, so let's look at this example here. We are given this linked list and the node given to us is equals to 3. So that means all the values less than 3 should come before all the values that are greater than or equals to 3. So let's take 1. 1 is less than 3, right? So it should come before, and now the next value is 4. The next one also is equals to 3, so 4 and 3 should come after all the values that are less than 3. So as for these three, it is satisfying the condition, right? But when we have the node 2 which is coming after 4 and 3, that is not satisfying our condition. So we need to move node 2 before both the nodes 4 and 3, and it should come after 1. Why? Because we need to preserve the relative order. That means 1 is appearing before 2 here in this linked list, and it should be the same here. So here 1 should appear before 2, and similar in the next case we have 2 which is also going to be before the values 4, 3 and 5, and it should be in relative order. So this node should appear after the node 1 and this node 2, which is these two nodes. So that it means this node 2 appears here, and the rest of the node which is 4, 3 and 5 should also follow the order and should be at last of the list. Okay, so this is our result over here. Now let's try to look at this example. I have modified this example a little bit. Instead of the node 2, I have a node 1, but I don't think that makes a lot of difference. So now let's look at this solution. Okay, so the x given to us is equals to 3. Here what are we going to do is we are going to create two different portions. Okay, so any value less than 1. Okay, so 1 is less than 3, so that will go towards the left part, and any value greater will go towards the right part. Okay, so since 1 is less, it will go towards the left part. Okay, but before adding this node to our left portion, we actually need a dummy node, a node to which we can append this result. Okay, so we are going to create a dummy node with a value equals to 0, and since 1 is less than 3, it goes to the left portion, and we append the node to our previous current value. Okay, so now our current value for left portion is equals to 1, and our right portion is still has dummy node which is 0, and next value here is equals to 4. So since that is greater, it goes to the right and will be the next of the current node in our right side. Now here we move our head. Okay, our head here is moved in both the cases, and here also we are moving our head. Now we reach the value 3. 3 is greater than or equals to x, so it goes over here, and then we move towards this position. So we keep on moving, and 2 is less than 3, so it goes towards the left hand side, and again we change our pointer for this list. 5 is greater, so it goes here, and now we have the value 1, and 1 is less, so it goes towards left part. And now finally we have reached the end of this list. So since we got our left portion and right portion, now we need to merge these two portions, right? So how are we going to merge these two portions? We added a dummy node here, we are also adding a dummy node over here, right? And to merge these two, the nodes that we are getting from the original list are only these 3, right? And this is the last node here. So this last node should be pointing to this node, right? Okay, and the last node over here should point to the null value because like it is the last node, right? And here if we do not do that, then what happens is, since 5 was pointing to 1, okay, so in this case also it will still be pointing to 1. The next of the 5 will not be changed until and unless we explicitly change it. So since it is the last node, we change it to the value equals to null, and in this way we merge these two linked lists. And what do we get is, okay, let me just remove these 0 values, and this is what we will get. Okay, so this is what we get. But now our head, we have a dummy node here also, right? And this is a dummy node, so we need to remove this before we return. So what are we going to do is, instead we are going to return the next of this node. So now let's start coding. So what I'm going to need is, we need two dummy nodes for the left and for right. So let us create new list node with value equals to 0, and same for the right portion too, list node with a 0 value. Okay, now that we have two dummy nodes, now we are going to iterate over each of the value in the node until and unless the head is not equals to null. So as long as we have the head, we are going to perform the comparison, and we compare the value of head with x. So if the value of head is less than x, then it should go towards the right. So left, it should go towards the left if it is less. So left dot next will be equals to our head, and our left should now point to the left. Our left pointer now goes to the next value. Okay, else what we do is, right next will be equals to the head. Okay, we add the node towards the next of the right, and our right pointer is now shifting towards its next value. Okay, and in this way we find our left and right, and also we need to move our head as a right. So head equals to head dot next value. And then finally what we do is, we need to merge the two. So for that we assign the next of left to equals to right dot next. Why right dot next? So we also need to maintain the first node of both of these list node. Okay, so what are we going to do is, left head equals to left, and right head equals to right. Okay, so in this way we have the first node, and the next of the first will be the next of our left portion, and the next of our right will be equals to null value. Okay, because right is the last element, and the next should be equals to null. And then finally we return our left head dot next. Okay, now let's run our code and check if this works. Awesome, it worked, and I have added few more test cases to check for empty nodes for at least one node, for one node where x is greater than, x is equals to greater than that value, for two different nodes, and so on. So now let's try to submit this. Great, so in this way we were able to solve this problem. And talking about the time complexity, as we are iterating over each of the nodes in the original linked list, so that would be O of n time complexity, and we are not creating any new data structure, right? We are just creating a node, and then we are appending the node from the head from the original linked list to our left and right portion. So that does not change the space, that does not consume any additional memory, so that is also constant time complexity. Okay, space complexity. Here I have also created one more solution with a different approach, where I am performing in position uh, changes. So you can have a look at this solution as well if you want to. If not, I hope you like my solution, and let me know in the comments down below, and please share and subscribe to my channel. Thank you so much.